Now, in the lead up to this conference, I asked intelligent business people from a number of states and a variety of sectors how much they knew about the water levels in use in their local catchment, how much was left in storage, how much was extracted from their local waterways to power the industries, and so on. I asked them, did they have that understanding? Did they understand the opportunity cost? The answer is no. None of them could tell me much at all. Now, as a systems strategist, I see water as the ultimate systems connector. From the clothes we are wearing today to the food we ate for breakfast, to the products in our homes, to our daily routines. Embodied water exists in everything we do. And yet for most of us, our relationship with water stops at the point in which we pay our water bill, which is far too cheap to communicate the cost of water, let alone the value. So let us ask ourselves, why is it that we can just turn on a tap and the water rushes out? Why are there no limits, no boundaries? Now, to put it simply, the linear economy has progressed us forward, but it is now holding us back. And worst of all, it's holding back our thinking, our curiosity, and our problem solving. So when it comes to systems change, there is a lack of attribution in the way we question the value of water. Communicating the value of water is the first challenge to truly implementing a circular economy within and around the water industry. You know, what happens when we start mandating embodied water content be accounted for across all products and services? Because my work in the circular economy globally tells me this is where we're going. Much of my work today involves understanding embodied carbon or embodied metals in supply chains. And I already warned you that I was forensically curious. So what does it mean, for example, when our Queensland government announces, as they did recently, that we are going to decarbonise our economy using electric vehicles? Now, the electric vehicle industry relies on the resource-intensive consumption of mining, which in turn relies on the resource-intensive consumption of water to produce metals. So how do we work back from the big announcements of the day to understand what it means for water and other finite resources? And actually, why should we be working back? Should we not understand the embodied content of water and the implications before we make these big announcements? To be specific, did you know that an electric vehicle requires 30 kilograms more copper and 15 kilograms more manganese than a traditional combustion engine? In addition, we also need an extra 10 kilograms of lithium, 40 kilograms of nickel, 13 kilograms of cobalt, and 65 kilograms of graphite. That is without tallying up all of the embodied carbon inherent within these various supply chains, or even the embodied water required to produce these metals. Now, if we just zoom in on lithium, more than half of the world's lithium resources lie beneath the salt flats in the Andean regions of Argentina, Chile, and Bolivia, where indigenous quinoa farmers and llama herders must now compete with miners for water in some of the world's driest regions. And lithium mining requires huge amounts of groundwater to pump out brines from drilled wells, and some estimates show now that it is using 2 million litres of water to produce 1 tonne of lithium. Now, in Chile's Salar de Atacama, lithium and other mining activities consumed 65% of the water, causing groundwater depletion and other forms of environmental degradation, forcing local communities to actually have to leave their ancestral settlements. So my question really is, when we make these announcements, are we fully understanding the system's implications? Do we have enough water to fulfill this promise? Is this the most valuable use of that water? Or do we just grab a headline and expect that the water will be there? Because when it comes to political value, somehow today's headline trumps tomorrow's water supply. And as one of the driest nations on Earth that exports over 35,000 gigalitres of fresh water through virtual water, which is the equivalent of 14 million Olympic-sized swimming pools each year, we need to lead the world in thinking more deeply and more critically about water and the bigger picture. Do we treat the problem, or do we treat the problem as an opportunity for transformation?